I'm going to try to show how we can make BIM projects a little bit easier. It doesn't have to be a very complex, intrigue process. It can also be made quite easy. Having said that, there is a lot of things related to a BIM process that, by definition, is not that easy. So we cannot remove all the obstacles, but we'll try through software showing you that it doesn't have to be that hard and lower sort of the threshold of getting started. Catenda is a company that is making an open BIM platform, which I'll be talking about today. It's called BIMsync, and it's a way to manage and distribute your building information models in a project. I'll go into details on how we do that. Catenda is a member of Building Smart Norway. We're quite active. We have been part of the small 5 to 10 people groups that are actually developing the Building Smart standards. My colleague right here, Lars Bjørkhaug, has been working on the Building Smart Data Dictionary standard, the ISO 12006-3, since 1998. Myself have been involved with a model support group that develops the IFC standard since 2004. So we have been working quite closely with the Building Smart international community to contribute all our expertise and experience in trying to generate very good standards. Our product is used around the world, and we have a deep building process knowledge background. Catenda was founded out of SINTEF, the biggest research organization in Norway, where we were in effect the building process department. So we spun ourselves out and we started focusing on using the Building Smart standards to generate software to help the building process go more smoothly. We have high IT skills, which you need in order to build a smooth cloud-based platform, and we're based in Norway. BIMsync is a platform where you can manage your models. You can have complete control of all the revisions, all the history. You can distribute it easily. You can manage issues, every single issue related to the project. You can visualize the models. You can validate models. And it's all cloud-based and interfaced through your browser. So you just fire up your browser, go to the URL, and log in. There's no installation of plugins, no nothing. That's all you need, a password and a username. We also have an API, which I'll talk a little bit more about later. What we want to do is actually to connect everything. And I'm not talking about taking all the pieces of data around the construction process and entering it into the building information model. I'm talking about connecting the data, linking the data, using the building information model as a connection box. And if you start thinking about it, it gives you tremendous power and has an immense impact on the information that you can use at every single point throughout the construction process. I mean, today, most of us have a pretty good control of our social life through this little device right here. It's almost as if you know when your friends have had, or what they had for breakfast. It's a very powerful tool through Facebook and Instagram and all that stuff. Now, it's really, in one sense, a puzzling thing that we do not have the same kind of power through this device throughout our construction process. I would like for every single person involved in the construction process to just pick up something like this and immediately get a very quick glance of what his or her immediate sort of information need is. There shouldn't be a need to go through bundles of binders or look in drawers for drawings or fiddling with all kinds of stuff. It should be possible to get that information right here. Sometimes you'll need a bigger surface because you want an overview of the drawing. Sometimes that's 2D, sometimes it's 3D. but the information should be accessible to you everywhere. And that's our goal. That's what we're trying to do. So, for example, logistics information, connect it into the BIM and have it right there so that you know the screw or the gypsum plasterboard or the ventilation system. Is it en route? Has it been delivered? Is it on the site? Where is it? You should know all that. BIMsync is a 100% open BIM platform, which means everything you put in is something you can take out, so the data is yours. BIMsync has no interest, or Catenda has no interest in locking you into one single platform. We believe that the best value for our customers is if we can have the most open system out there. So it means everything you put in is or you can take out on open international standards. And obviously, we're using the Building Smart standards as they are. I mentioned the BIMsync API. The API is an application programming interface, so essentially allowing any other software system to interact with our platform. What that means is that, for example, a calculation system or cost analysis system that doesn't yet have BIM capabilities can gain BIM capabilities quite quickly by using our API. The viewer that I'll show you is part of the API. So you can have an embedded viewer, and nobody using any of these software does need to know that it's coming from BIMsync. We are totally open for a white label integration in a sense. So that any software that you already have today, and if you don't think that they have been following the trends and is up to BIM speed in a sense, and you want them to have BIM capability, have them contact us and we can get them up and running in a matter of days, in fact. Some of our clients have been able to put up a demonstration within a few days, and I'm not talking weeks. So it's quite quick and easy to do. Here are some of the customers that we have. This is a French project management system that has just added BIM capability. This is a facility management system from Iceland, chosen by the biggest Norwegian state property owner, a public client in Norway. So they have publicly said that all their buildings, existing and new ones, is going to have a building information model on an IFC format, which means that main manager, through our system, through BIMsync, will have BIM capabilities for that client. IES is a client in the Netherlands, cost calculation, and this is a project management system in Norway. So I was talking about this being an open BIM platform. Many of you may know this same system by the name of a BIM server. We think that's a little bit of a limitation in a sense, since we're not really just looking at how to manage our building information models, but we're trying to connect information. And an open BIM platform means that it's open, as I said, and we want to be able to have all these things connected. So the electrical, architect, HVAC, structural can talk to the open BIM platform. Fire numbers, the fire consultant can add information, the sound consultant, energy, and so forth. Everyone should be able to work on the same shared BIM. So you've seen probably yesterday a few slides talking about a shared model. So we're not talking about a centralized BIM where everything happens inside that BIM. We're more talking about a distributed BIM. So, for example, the architect has his own building information model. He may collaborate with his team through his own BIM server or model server or what have you inside the architectural office. The same goes for the electrical engineer, the HVAC engineer, and so forth. But the project somehow needs to have a common ground. So what we try to do is to make sure that the project have an easy access to all those building information models that comes from all these sources of authoring. And we work throughout the whole construction process. So we're starting way over here in the design process. Once you have established a few objects, it doesn't have to be geometrically correct, but the object can be captured in the IFC model, get them up there. And throughout the construction phase, I'll show you how you can add real product data. And then in the maintenance phase, for example, through our partner Main Manager, the BIM still lives and survives throughout the whole process. And that's the goal. But the first step you have to think about in a project where you have different building information models from the electrical engineer, the HVAC engineer, and so forth, is that you need to establish a common reference point, which basically means that inside the BIM authoring tool, everybody needs to kind of have all the coordinates in reference to the same point. Otherwise, the architect model will be here and the electrical model will be over here and nothing will match. Now, this seems to some of us like a really easy, simple thing, but it turns out that it's not that easy. And even some software or some people have experienced that for my software, but I need to make sure that the Y and X is always positive. Once I start getting negative X and Y's, I run into trouble. I don't know why. And it shouldn't be like that, but that's the case. So be aware. This is the first thing you need to take care of. If you can do this and coordinate this, you'll be fine. And then you have models. This is the user interface in terms of creating a model inside BIMsync. I'm now standing on the dashboard, and nothing, this is an empty project, nothing has happened, and I need to start adding a model. So I click on the plus button to add a model. And in BIMsync, we're thinking about domain models in a sense. So you can have as many models as you like. That might be one model for the architect, one model for the electrical engineer, one model for the HVAC engineer, and so forth. Or you can have one model for the east block, one model for the west block, or one model for the east block for the architect, one model for the east block HVAC, and so forth. There is no limitation on what you can do. So you divide this up into the divisions that you feel most natural to your project. So it's totally flexible in that sense. So one project can have many models. And for each model, there will be many revisions through the time. So for example, the architect will start uploading his first revision. And then he'll do some remodeling and change some things after the project moves forward, and he'll upload a new one. And he'll keep on doing that. And as he goes, as the project moves throughout the time, you'll have more and more revisions coming in. So we take care of all that stuff. We keep the complete history, and you have access to every single revision in every single model in your whole project at any single time. So in this sense, you don't have to worry about file names, actually, although you might want to do that after all. So what we do is we have a drag and drop. So I've created a few models, and you go from your file system and you drag and drop the file up there. I'll show you. So I'm right here inside the same project. I already have my architect model. I can go to the models, and I can pick up a local file. Sorry. Let's see if I can find a model for the electrical stuff here. Where is it? Here it is. So I drag and drop, let it up there. I write a comment to tell what this is about. First import, I submit it, and up it goes. And as this goes up into our system, we do a number of things with it. We store the file, we process all the information, we extract a lot of information, cache it, generate indexes and stuff like that. So we generate some geometry, and you can see right now it's processing. And once it's done, I will get a notification saying this is done. This is going live now out on our server because I think that's more fun than just watching PowerPoint presentations. But it will take a little bit of time to do that. I can do the same with the heating and structural as well. But I'm not going to do that. I won't waste your time. Okay, so you have a very simple way for the architect, the electrical engineer, and so forth to add their models to the project. All he has to do, or she, is to export from his BIM authoring tool into an IFC model, and to make sure the reference point is the same. If that's done, no problem. He can do, any one of these guys or gals can upload the model as often or as seldom as you like. If you run the project, you can have them do this every hour, or every minute, or every week, or every second week. That's up to you. But it shouldn't be hard for any of those involved to drag and drop the file into the right place. That's it. Another big thing about a project is issues. I'm going to show you a few slides or a few images from a real project. This is a project that's we've been involved in Norway, and it's very typical. This is how the HVAC engineer thinks he should build the building. It's a remodeling building, but he had to redo a lot of things. These question marks kind of is not very comforting in a sense. Does he know what he's doing or what's going on? And it's quite unclear of everything. This is good in an early stage where you're thinking out loud and doing things, but it's not great for communicating. It's not great to hand into the project and say, this is what I'm going to do. So it should be a little bit better. And this is what happens. It's the same project, the same guy, and this was discovered and showed to him in a meeting, and he said, yeah, well, it's very hard with the 2D drawings, you can't see everything. So that's his answer. So that's why you need the 3D information sometimes. And 3D information is complicating things a lot. I've seen, for example, in the same project, the project manager, she's computer literate, no problem. She really loves the idea of using building information models to get better control and better quality of her project. But she finds it difficult to navigate in the 3D world. Another participant in the project, he's, I don't know, maybe 30 years old. He's been playing games his whole life. He has no problem. So she hands the computer to him and tells him, can you show me this and that? And he boom, goes through and there we are. So it's a generation thing. But sometimes it's necessary to have the 3D information in order to get to the real issues. So what we did, we tried to combine this a little bit by saying that you can create an issue and you give it a title, you say something about the problem, you may assign it to somebody, you can say what kind of type it is, and you take a snapshot and you annotate it with circles highlighting the issues that you want to discuss. This is probably something that you've seen everywhere, and so we had it as well. So now you have an image, 2D image, that tries to explain the situation by circles and stuff like that. If you click on the image, you'll get the same view of the model, and this is a live model, so you can turn it around and play with it. I can show you that. So I'll open up the model, and as you can see, the processing of the electrical engineering thing is finished. And I can go to the issues, and I can open the same issue that you saw by clicking on the image, and it will take me straight to the same thing. It even includes the clipping plane that I had when I made it, so that you can kind of change the model like this and look at things in more detail if you like. And remember, this is just happening in your browser. There's no plugins, nothing. It just works. And you can add other pictures and other things to the same issue to try to explain what you're trying to do. We also have an overview of all the issues in the software itself. So right here you can see a list of all the issues in there. There are some graphs trying to illustrate and visualize the status of your issues. So for example, this one gives you an accumulated status of the issues, and it shows you which ones are open and which ones are closed. And hopefully as this list grows, the list of closed issues grows with it. You also get a type distribution of telling you if there's an error or warning or what kind of issues there are. And you can sort on all kinds of things. We also have something that I think is not that common out there. If you click on an issue, you'll also get a list of the related issues. And the way we do that is that every single issue is usually connected to an object in the BIM, one or more objects in the BIM. And if you click on an issue, we will also list every single other issue that deals with one or more of the same objects that this issue does. So in this case, it's quite useful because the window is too small, is one kind of problem, and another one is move the same window. So if I want to change the size of the window, I would like to know if somebody has asked to move it, because maybe if I change the size, there's no need to move it. So in this case, you get a better view of the information you have at hand, and it saves you from some trouble. The flow that we have thought is the best one for an issue is something like this. You create the issue, you assign it to somebody, they work on it, handle it, and maybe they have to reassign it to somebody else because they couldn't complete it, and at some point it's completed. There is a lot of information added to the project as you work on issues. We have talked to some clients that are interested in knowing which one of their subcontractors spend the most time solving issues. Which means that if they have complete control of this, they can look at subcontractors and say, this guy, he's too slow, let's not use him in the next project. Or this guy is really fast, let's just get a better deal with him and use him for all our projects. So there is a lot of information that you can utilize in this. We also have the possibility of exporting this to a BIM collaboration format. That's part of the Building Smart standards, which means that if you have a list of issues, you can either export the issues that you have filtered, for example, only mine issues or only somebody else's, or you can export all the issues. And that means that you can take issues, for example, into Revit and continue working on them there and take them back in later on. So that means you have a complete trail and history of all the issues. And that means if you're in Revit and you click on this viewpoint, you'll get the same viewpoint inside Revit. And of course, with the Building Smart Collaboration Format 2.0 and the API coming up, you don't need to export this anymore. It will just happen live automatically. As this is a BIM or cloud platform, we will implement the API, and in Revit, if they implement it, you can just point it to the right server, our server, and it will just work for that project. We also have a capability of enriching models. So what this means is that you can add information into the model. And we have based this on one sort of simple premise, that you don't add a lot of information and we store it in the IFC file. You add a simple link so that it's accessible from the BIM to the external data source, and if the external data source supports it, back in. The external data source only have to give a URL, and it gets right back into our platform. Let me give you some examples on what you can do. This is what an example of what it can look like. I have clicked on this object right here, and this is an excerpt of the information inside the building information model. But in addition, I have issues. As I told you, these two issues deal with the same object. So you get them right there. And here is a CoBuilder Pro connection. So it's an actual physical product that the project has purchased, and it has arrived on the building site, now connected to this wall. So I can click on this here and open up a link straight into the database of CoBuilder and get all kinds of information. We also, of course, have a connection to the Building Smart Data Dictionary. Nobody else has this in terms of open BIM platforms. That means we can say that this wall is actually a timber framework wall, give it a GUID or a GUID or unique identifier from Building Smart Data Dictionary. And that's global, which means that we know exactly what type of wall this is. We also then know what kind of products from CoBuilder's database, since they're based on BSD, can be used on this wall. It gives you a very powerful way of very quickly connecting external information, in this case product information, to the building information model. Which means once you're doing this in the construction phase, when the building is up, the as-built BIM is ready, and you can just hand it over. Give them an IFC file, or give them a link to the project in BIMsync. Yeah. This is how it looks like when you open a project and you haven't done anything. We have, by default, the connection to the data dictionary. I'll show you how you can add another one. So I go into the menu of libraries, and as you can see, I already added the CoBuilder Pro library connection, which means that I've just connected a project in CoBuilder Pro with my project here. It's a simple setting of adding a number, an ID. I click here to add a new connection, and we have a few of them here. I choose Dropbox, and I give it a name, let's say drawings. I add it, and now I'm asked to verify since I already did this, Dropbox has, if I didn't do this before, Dropbox would ask me to say, are you sure you want BIMsync to access your files in Dropbox? And you give it yes or no, just like Google and Twitter and everybody is doing. And then I can select a folder from my Dropbox account. This is my live Dropbox account. I just select one folder, and now all the subfolders and files in that folder will be accessible to BIMsync, which means I can link any object in that folder to any object in my BIM. Now that it's connected, let's see how we can do that. Just open up the viewer right here. I can, for example, click on this wall. It's already connected to CoBuilder Pro. If I click on this, I can open product information. I'll show that afterwards. But let's tag this with a file. So I choose drawings, and I list all the folders or files that is in this folder. So there's a drawing. I add that one, and now you see right here, and I can download it. So simple as that, you connect external information sources right into your building information model. You're not bloating your BIM, you're just linking. And I can do the same by choosing a different library, in this case CoBuilder Pro. What you're seeing here is actually quite powerful. This list right here is a live list from the CoBuilder system. They have an agreement with all the suppliers in Norway, which means that when a project goes into the store or orders something through their e-commerce system, there's a message from that e-commerce system to CoBuilder saying, this project, this purchase, this product. And the moment that happens, this list can show up here, which means this is the list of all the products being actually purchased on this project. Okay? CodeBuilder also have a mobile system. So if you purchase a product because you ran out of painting and you have to run to the local painting store and they were not part of this bigger network because it's a local guy, you bring the painting box onto the construction site, you use the app from CodeBuilder and you just scan the barcode and say add to the project and boom, it shows up here. It's a very easy way of getting products into your system. And using the Building Smart Data Dictionary and all kinds of technology, we can really do this effectively by just filtering out what's not necessary for all these type of products and filtering out that and this. And then, once this is in here and added to an object, I can open the product information page from CodeBuilder. This is a live link into their database. And I'm not sure about the connection speed here today, but here it is. These are actual properties, and I have documents and safety nets, but safety data sheets, environmental information, everything. And just to show you, they're using the Building Smart Data Dictionary, which means I can translate on the fly all the properties that you saw here to English. It just happened. It's real data connected into your building information model. Boom. For example, here's a way of showing all the objects that has been tagged with this particular product. So you can do all kinds of visualization once you have this in place. Any questions related to this? Yes?
I have a question. I'm wondering how's the tagging process? So initially you have a model and it's not attached to the data dictionary. So what's that? Is it an automatic process or a random process? And similarly with the code builder, who's responsible for assigning it, and what's they may assign the wrong product to the wrong builder?
Yeah. Just like any quality assurance, you have to have some quality assurance in place. What we're building into this is an automatic system, so that we'll sort of automatically tag the building information model with data dictionary tags, which means that the filtering process, when you have thousands of products, are quite efficient and quite easy to do. But obviously you need some quality assurance in that. So you need some people to go through and see that everything looks good and right and everything. But I'll tell you, if you get 80% right, it's eons better than what we have today, where there's nothing. So you'll in any ways, you'll have gained tremendous value.
But is there a possibility of, for example, having rights so that someone can log in and there's a specifier, and they can then make those connections, and other people can view it but not connect or...
Yeah, that's possible.
Yeah.
I mean, this is sort of like an open platform, and we know who's logged in at any time, so we can turn on and off access rights. We have a trail of who does what, so you can view the log and all that stuff. So it's very flexible in that sense. We can also visualize, of course, any building. What I've done here is to say that the architect model should be transparent, and you can see everything else. I've also added a clipping plane to just move it, and you can see all the other domain models in there. I can show you a little bit of this.
So just one question.
Yeah.
The scanning, that's off the barcode of the product.
Yeah.
So just scan the barcode.
Yep. CodeBuilder also have, if I may, Lars, say that if for some odd reason that product is not in their database, they will react quite quickly in adding it to the database.
It flags up on the system and maybe change it.
So they have all those processes in place.
I just make a comment on this whole thing.
Yeah.
There's a lot of things to be discussed when you're talking about products, because there are a lot of regulations, there are demands for eco information, so classification,
Yes.
How can we replace products? For instance, you have one project that was established on the design type of paint, and then on construction, we want to replace it.
Yeah.
We can tag it, but how does it work there?
This process that I showed you right here happens in the construction phase. So none of the projects shown in that list, or all the projects shown in that list, have been actually delivered on the site. But there is no problem changing this. I mean, you can highlight things and you can just easily, quickly change if there's a new product coming in or whatever. So that's a process easily.
Again, just to comment, a lot of discussions around this.
Okay, so let me just show you a little bit of the navigation. This is a very standard viewer in many sense, except that it works in your browser. We can handle much bigger projects than you see here, but I don't have access to any larger models that the clients are willing to let me show everywhere in the world. So all I have is this demonstration building right here, which is a small condominium. But I can click on things, I can hide it or show it again, I can make it translucent. I could here select the whole building and make that translucent, and then you can see the electrical model that I added showing in here. I could also go inside the building and kind of navigate around by viewing things and going through walls, looking around in the building. It's probably easier if I take away this. Get a kind of feeling for how this looks. I can look up and down. I can descend through the roof and get down in the basement. Look around again. I can also increase the angle of my viewing perspective, so that it's perhaps easier or worse to navigate around. So you can do all this stuff as you would expect from any viewer, I guess. Let me see if I can also I can add a clipping plane or more to cut through the building. Viewing angle is a little bit steep. So you can cut through the building, and you can do that in many ways. I think you can have 6 of these. Oops, wrong one. Six of these at any one point. So they will intersect each other, and you can do this stuff.
Comment, these plans, they align to any surface you click at. So it's,
Yeah.
you don't need to have it like rectangular or flat. You just point on the object you want to align to, and it will align the plan to that.
So you see here is a
Question?
yeah.
Is this using is this a plugin or is this a WebGL implementation?
This is using WebGL, yes. So it's a standard implementation. It actually works on Android and iOS as well.
I noticed that you're using Bootstrap. How do you guys, so if you were looking at this on an iPad,
Yeah,
and then, so obviously you've got
yeah,
different formats, it then reconfigures how
yes.
it works.
The whole system reconfigures depending on the size of your screen.
You're using Bootstrap. Is your-
Yes, we're using Bootstrap.
Because I noticed that MBS's toolkit, the BIM toolkit,
Yeah.
quite works, they're using Bootstrap.
Yeah.
And it's a good thing because it makes things look consistent.
Yeah. It's a little bit more, it takes a little bit more than just using Bootstrap, because you have to decide which elements should show and not show and where they should show as the screen changes. So it's a little bit of a,
You get different templates of drawing it.
yeah,
Some of them are things like put little menu strips outside
yeah,
and stuff like that.
exactly.
There's lots of ways in it, but the basics of it are that we've made it so that it's format friendly.
Let me see if I can show it to you. So this is our dashboard, and if I change the size of it, you'll see how it just adapts. So see, notice the menu on the left side,
Yeah, that goes to the strip.
yeah, and it goes away totally if I go on the mobile phone.
It also means that the data is a lot faster. So if you're on a mobile device, then
Yes.
it's a lot easier to get the.
Yep. Okay. So just to sum up a little bit of what we've been going through, we've shown how you can manage models, drag and drop them into the BIM platform. That's it. We have complete control of all the revisions. So anytime a new drag and drop comes in, it's a new revision, and we keep the history. Nothing is lost. We have models. You can have as many domain models as you like. You can split the project up into anything you like. We manage issues. So you can manage all the issues, and we like to connect them to objects in the BIM, which gives you a lot of power. You can visualize the models. You can validate them. I haven't showed you that. I'll show you screenshots afterward that kind of gives you an idea. It's cloud-based, which means it's connected to anything. It's available for anybody, anywhere. You saw how it adapts to the screen size. So it's browser-based, and we have an API, which means that other software systems can easily build in BIM functionality. Because we handle all the nitty-gritty details about uploading a BIM and visualizing it and connecting all of the different things and controlling all the objects, stuff like that. This is a screenshot of a report, and it's based on the big public client in Norway. They have a manual for what they like to have their models structured, and we validate according to that manual. And you can see here some of the units have not been correct. Naming of the project is out of whack. Building numbers is not according to their standard, and so forth. So it's possible to validate as I upload, as you drag and drop. We can, among the number of things we can do, we can also validate the model and giving the users, the project owner, a report on what's the quality of this BIM that you just got from your subcontractor. The last point that I think is quite important. Obviously this is more towards the level 3 BIM here in the UK. You may have noticed that there's no mention of Kobe drops or Kobe exports. That's something that we do not have, to be completely open and frank, but it's very easy for us to implement. It's just an export. We have all the data, we have all the models, we even have product information through CoBuilder. So it's easy to pull out an extract of that into a spreadsheet.
So,
Yes.
or somebody could write an application using the API.
Obviously, yes. So that's possible as well.
In the sort of BIM server from a few years ago, that I started, the concept was having lots of people having their own BIM servers,
Yeah.
and then being able to each then tap into each other's.
Yeah.
So the engineering side of it, or the architectural side of it, run their own, but they could then call on that to bring that together. So in terms of federating somebody else's model
Yeah.
from another BIM, from another
Yeah.
server, do you support that, or
We
is
haven't.
that just not an environment that's safe enough for?
Yeah, no, yeah, exactly. We haven't seen that need for it, but obviously we have. It's a platform, so it's easy for us through some other API, and of course the BIM-C, I think, it's a project trying to standardize APIs that accesses building information on all servers. We will obviously support that since we're so much into building smart and open standards, and that opens up a lot more opportunities. And among those are things like you're talking about. And one of the my background is mathematics and then software engineering. And in the software world, it's been a very interesting development. And what's all the rave right now, what everybody's using right now, is something called GitHub or Git, which is a distributed way of working on the same project. So essentially what you do is you have a project, this is the central repository, and then you pull everything down and you work locally. You have everything here. You have the complete history of the project, everything. You do your things, and once you have completed your little fixes or changes, you you take a package of only the difference and you send it out and you say, you or the central server can just pull it in if you think it's quality good enough. And obviously that's something that might happen here. I'm not quite sure because there's so many things that you need to think about when you're modeling and authoring BIMs. And there's so many complications with a 3D model. It's not lines of code. There's much more things to think about. But if you think far ahead in the future, this might be something that we might see.
Yeah, and GitHub also has this branching.
Yeah. Yeah.
And so you can say, work on a version of
Yeah.
like that here.
Yeah.
So there are great aspects of the program environment that could
and we're inspired by
will
it.
just benefit from those. And they also bring comparisons between what's changed.
Yes. You have your hand up there, Lars?
Yeah, I just want to say that we build part of our technology on the BIM server org initiative, and that's why, for instance, the rules that are waiting for that platform can be run inside BIMsync as well. But we're also looking at supporting, since we want to have a really open standard with this, and the XML is the obvious choice coming up now. That's why this part is in the project just for the moment, but it will come back as part of the
So my final point is that in any project that you run, you might want to, maybe you don't want to do all in BIM at the first take of it. You might want to just try it out a little bit and dip your toe into the water or whatever. Depending on your structure, your incentives and all that. We think our platform allows you to go all in or just a little bit in. You can use this as just to manage all your models, as a model repository in a sense. That's it. You don't have to do anything else. You can in addition have other projects, repositories if you want to, but this is an easy way. You don't have to think about file names, you have all the revisions, everything. Or you can just use it for managing issues. Forget about the models. Just manage your issues. That's it. Or you can do a combination of the two. If you do it for managing models, you automatically have visualization of it. That's powerful. Or you can start validating and you can start connecting with the API, you can do all kinds of stuff. So there's an easy way of just starting, getting to know this, maybe do it in parallel of the project, maybe including it completely. This is all up to you. We try to design a platform where it allows you to decide how much involved you want to do and when your pace of getting involved in building information models. So that was my final point. Thank you all for attending this workshop. If you have any further questions, feel free to get in touch with me, Lars Bjerkhaug, or Glenn Marcus, who is also, if you can show your hand, Glenn. We will be here all day. You can go to bimsync.com and sign up or ask for something. Good point. We have a stand, so we'll show you whatever you want to see. Thank you very much for coming. Thank you.
Thanks for coming along to this. We won't take an hour to get through it. We'll just get through it as quickly as we can. We'll have a little bit of time for Q&A at the end. But by all means, if you want to ask questions as we go through, that's no problem. My name's Sarah Graham. I'm joined by my colleague Neil Gibson at the back. I'm the UK division head for IES. Been in the company for about 8 years. Prior to that, I ran Atkins Building Physics Department. And in that role, I was sponsored to do an engineering doctorate at UCL. So a lot of the people that are here from Building Smart and UCL and Atkins and various other places that have been talking about all this stuff for a long time are colleagues of mine. So it's just to give you a bit of background, I'm not just here as IES. I have a vested interest in what's going on at the moment. My own research was based around integrating design technologies for better building design 10 years ago. Before that we were still talking about IFCs and implementation, etc. So there's all that going on in the background, but today really want to just give you quite a succinct overview of how we fit into a BIM enabled workflow. Okay? So IES, Integrated Environmental Solutions, the virtual environment is the software, building performance analysis is what we do. And I'm going to talk a bit about that. I've got a few slides by way of introduction and scene setting, and then I'm actually going to just go into the software and do a demo as well. Fingers crossed. Don't shy away from the demo. Okay. So we've heard a lot over the past 2 days at least about government strategy and why we're doing all this stuff. What is BIM and what does it mean on construction projects and through life of assets? Where we fit into that is really the capital cost, running cost, life cycle assessment and sort of energy in use side of things. So I would say how we respond to level 2 really is in creating, capturing, analysing and exchanging data during design, construction and operation. Okay, so talking about capturing data, doing stuff with it and keeping the data, the information alive into the operational phase of the building. Just one slide on who we are. So we're a UK company headquartered in Glasgow. We've been around for just over 20 years. We have offices around the world and we're dealing with similar issues that we've been talking about here for 2 days in all of the different countries as well. We have a large R&D programme. About a third of our company really now is devoted to research and development. We've been very successful through TSB, which is now Innovate UK, and also EU funding, so FP7 and now Horizon 2020. We've got about 9 EU funded projects running at the moment. All of the R&D falls under these 5 headings. Okay, so we look at design, we look at individual buildings, we look at scaling that up to a master planning level, we look at site-wide energy strategies and all that sort of thing. We're also looking at things like closing the gap and how BIM lends itself to that, the performance gap that is, and that's really what I'm going to be talking about today. We develop optimization tools for early stage optioneering, what's the best orientation, what's the best optimized glazing percentage or whatever it might be for a building. And then we're also taking that into smart retrofit and refurb of buildings. The UK government have got quite a large amount of money going into retrofitting and refurbing existing buildings for obvious reasons, because that's where the carbon and the sort of cost savings and things are will be most evident. New buildings perform quite well, typically, and they're only a very small proportion of the building stock year on year. Okay, so what I've done here, I know the text is too small even for me to read, so people at the back, no chance. But in the pack that you've got, there is a little brochure of ours, and this diagram is replicated within that. What I've done here is just to take the plan of work, if you like, the stages as they're now termed, and the sort of main actions that happen, particularly with regard to soft landings. So what do we need to do right at the start? What are the ongoing actions through the process, and then into the operational phase of the building as well? What information are we trying to create and capture and utilise? And at the very bottom of that then I've kind of appended where our technology fits into that process. So what are the sort of things that you would want to do at each stage to basically to capture and to evaluate and to demonstrate compliance or conformance with the employer's requirements that have been set out at the beginning. So this is the BIM strategy. So I've taken the plain language questions typically at each stage and then how the software responds to that. So in the demo I'll take you through a use case to explain the process and actually produce the outputs that would respond to the client's performance-related KPIs. Okay. So we go right through, and I mean, pretty much focusing on aftercare. So, you know, what happens when the building's handed over? It may be a fantastic building on day one, but after a year or 6 months or 5 years, what's changed? You know, as soon as you put people into a building, everything's up in the air from a design and an energy prediction and performance analysis point of view. So we need to try and capture what's actually happening in the building, and we need to compare that perhaps with the design scenario or even the kind of early operational phase of the building. And we need to understand, because typically buildings do consume a lot more energy than they were ever designed to, and there's various reasons for that. And here we've got an example which I'll bring to life in the use case just shortly. We have the blue line is a typical design stage assumption for a lighting profile in an office. So we can see that it drops off at weekends and things like that. The red line is measured data from the building in operation. So we've been able to go in, we can pull the data back into the simulation software and we can compare the two. We can see then that the pattern is not that different. It's sort of dropping off lunchtimes every day and then dropping down at weekends as you would expect. But the loads are actually double. So that's got quite a large impact on the annual lighting energy for the building. It's more than double. But it also has knock-on effects on the heating and cooling as well. So, you know, the heating plant probably doesn't run full tilt because the lighting is actually heating the building and stuff like that. So we can start to really drill into how buildings are being used, you know, asking questions around why we're getting these sort of things. Is it because in the design stage scenario we've assumed some sort of lighting control which hasn't actually been installed when the building's been constructed, or maybe it's just not working? You know, just start asking questions about that and figuring out where the energy's going. I'm just going to reference SIBSE TM54, Technical Memorandum 54, which was published, I don't know, about a year and a half ago now probably. This sets out a very clear methodology for accurate design stage energy prediction. So very clearly saying don't use the NCM, the Part L national calculation methodology that we have. Although that's got a set of templates and usage patterns and profiles and everything for buildings, it's very much a theoretical exercise. So it's saying this building operated in this way will produce this much carbon, will consume this much energy. But buildings in reality, you know, it's only looking at regulated energy end uses anyway, which is lighting, HVAC. It doesn't consider things like plug loads or catering loads, or particularly server rooms, any process energy in the building. It doesn't consider out of hours use as well, so evenings and weekends, which is, you know, can be a fairly typical scenario for buildings. So what this does is very clearly demonstrates the difference that you will get by doing a Part L calculation in a building, which is a compliance scenario, versus a real building design scenario. So we can sort of make our own assumptions, or we can use previous project experience, or we can refer to some standards. There's different sources for building, and actually the TM54 itself provides a methodology to work to. So this shows then the comparison. The middle bar is the TM54 estimate, so that's like the real building estimate, and then the building in operation is this third bar. So you can see there's a bit closer, and it's largely attributed to the fact that the lighting, the fans, pumps and controls, which is the green amount, is considerably greater in the real building scenario than it is in the compliance scenario. So those are the sort of things that drive what we do. It's just understanding better how buildings are actually working. So we can view whatever data is collected within the software. We can use it, as in the previous scenario, to actually drive, we can use those profiles and things in the simulation as well. So rather than using an estimated lighting profile, we can use the real lighting profile from a previous building. So schools are quite a good example of that, where somebody may be gathering information, pulling data from that, a school that's actually functioning. We can then bring that in and use it in our design of the next school project and start to really understand properly how the building will be used. What we're looking at here is heat maps. So this is actually half-hourly AMR data, gas and electricity, just main income and supplies into a building, which in a lot of cases for existing buildings is all that's available. It's not usual for there to be a lot of sub-metering and stuff going on. However, I think the point here is that is probably set to change. We've heard about big data related to buildings. That for us, this is where sort of BIM moves into the realm of big data, because going forward, buildings will produce a lot more data. So what can we do with it? How can we use it and benefit from it and build it into our design to inform the design a bit more? So I'm not really going to explain much about this. Suffice to say that the bottom heat map is gas. So we can see quite a random gas usage in January, February, March of this year. But if we look at the same gas data in the back end of the year, November, December, you can see a more regulated pattern there. So that would give us the insight into the fact that maybe there's some controls, maybe the controls were already in there, maybe they weren't working properly, or that some controls have been applied. And we can just start to look at that and ask questions around it, use our expertise to ask questions. Okay. Just to, I suppose, emphasise the point again about enhanced commissioning, because we can pull data from the building in operation, even during the commissioning stage, we can be pulling information from that. We can look at, are the systems set up correctly? Are they working properly? Do they fit the needs of the building at that time? And understanding the usage patterns, emergent usage patterns as well. So we've done quite a lot of work on this sort of thing, and there's plenty of examples of that on our website. You can go and check it out for yourselves. Okay, this is the fun bit. Not. So I just need to project. Okay. So what I'm going to do now is just actually go through a demo of the stages that we looked at and the sort of analyses and outputs that we would be producing using the software. The first little bit I'll do is maybe a video. So we're looking at creating, capturing, analysing and exchanging information. The first stage then really going through the project stages is master planning. So we have a set of master planning tools which use OpenStreetMap. You can basically key in OSM and it will open up the link to OpenStreetMap, which is an open source community uploading information about buildings and landscaping and whatnot, and you can actually pull that data back into the software. So what this does is allow you to create large models very quickly. So what you're doing, you're plugging in a location and a radius, and it will pull all the buildings and sort of, roadways and things like that from that map into our software. Once in there, you can actually, they come in as block models, as you'll see in a little second, but you can apply stories then to those buildings, and you can apply some early stage information, again the usage patterns, profiles that we talked about before. So ideally you would have, a school, an office, a residential apartment. You can apply those sort of templates of data to these models, and then you can start to run simulations. You can look at energy profiles. Looking at large scale, you'd be looking at the synergy between building different types of buildings. So, basically offices are full of people when homes are empty and that sort of thing. So you can share energy, you can develop site-wide energy strategies using sort of district heating and cooling, etc. for these sort of studies. But even for your individual building design, you can be pulling in the surrounding buildings to do, availability of daylight for your particular site, How is it overshadowed by other buildings? Is that going to affect your shading design or your PV location in the building? That sort of thing. Okay, so that's a large scale sort of master planning side of things. The next thing that we can do before we've actually got any building model as such in our software is we might want to look at things like climate and bioclimate. So what particular aspects of this site and this location should we consider as part of a sort of a lower energy or however you want to look at it, a green building design. So we can set location. We can use the wizard to do that. We've got quite a comprehensive suite of weather files that are shipped with the software. You can bring your own weather data into that. The climate files that we use typically are historic weather data. And they are made up of 11 different weather parameters, so external temperatures, direct and diffuse solar radiation, wind speed, wind direction, so that you can simulate the building in a location with sort of relevant weather data for that location. Okay, so all I need to do there is just to assign set location, and then I can run my. It's not liking that, I didn't think it would. So it's a bit behind, that's what's happening there. Okay. See, this is always going to be the case, isn't it? Yeah. Damn. What about if I just close it down and open it? I'll give it another go and then I'll resort to the recording that I did this morning, which is a bit rubbish really, but otherwise we'll just be sitting here till next week. Oh dear. Okay. That's better. Right, so I can just, once I've completed a task here, by way of actually managing my way through the process, I can click on the time and date stamp and it will show who carried out the task, when and where. So the next thing I want to do is, based on that climate file, I want to get a headline report out of here. Sorry, don't know why it's... Okay. Right, so that's produced a little report for me. Again, presented in a very simple way. So it gives me a climate classification. Okay, if we're used to working in the UK, we know what the climate is, so we can design with these sort of things in mind, but quite often we're working in locations where we're not maybe so familiar with the climate. And this will give us guidance on what sort of things to be mindful of, I guess, as the design starts to take shape. So even before there's a building model, any sort of massing model or anything available, we can look at things like the fact that winter's the most dominant season, so we look to minimise heating energy in the building, so reduce infiltration, good U values, etc. Things like diurnal swing, so difference in temperature daytime to nighttime. If it's good, as the notes suggest here, you can take advantage of nighttime cooling and thermal mass in the building, so that therefore reducing your dependence on mechanical systems. So that's quite a useful one. The next one is bioclimate. So this goes into a lot more detail. But again, for no effort or time on my part, I can get some useful information out. So again, we go through the climate, classification, mild winter, temperate basically, and it will give you design priorities. Okay, so things to really consider within your design. It looks at the urban street pattern as well, what sort of things are going to be beneficial. So again, if we're looking at a larger scale development rather than an individual building where we've got some influence over these sort of things, it can give us some guidance on that. The macro and micro forms, so the layout of the building, construction types to consider, super insulation for example, windows and openings, shading, and right through to passive and active, and even the HVAC systems which would suit a building in this climate. Okay. It's based on seminal text, so these references give you where this information has come from. It's not just IES dreaming it up out of thin air, it's actually referenced. Okay, so the next thing then that I want to do is look at availability of natural resources on the site. So can we make use of wind energy, solar energy, or rainwater harvesting for this particular building on this site? For this, I do need a simple building model. So I'm going to import a GBXML file for ease. We can do this in different ways. We can import IFC as well. So yeah, you take your pick, depending on what information, what information it is that you've got available, basically. But at this stage, we want a very simple model because we're still at briefing. We're still at the very earliest stages, and we're trying to really pursue an informed design. So have these sort of things drive the design so that when it comes to it, you'll fly through your compliance requirements, your BRIAM, your Part L, etc. without a second thought, because you've taken into consideration these key design factors right from the start. That's the idea. So as I bring the geometry in, I want to actually perform some checks on it as well. I want to check for closed shells, intersecting spaces, etc. And the software will do that for me. So just load the file again. It takes it tells you 19 seconds, 3 seconds to import the file. So this report now is produced to report on those checks that I've just asked it to run. Okay, so we see 40 spaces were imported out of 40, which is good. It tells me what controls are applied, that there's a set of preferences within our software where I can control what geometry is considered and how it's actually imported. It tells me as well what work the healing algorithms within the software have done to fix that geometry. So if there's holes in the geometry where there shouldn't be, the software will heal bits of that, and it will change orientation of surfaces to make it make more sense. So basically you've got the raw format and then the processed spaces. And you can just save this report out for future reference. But it also just gives you at the bottom number of spaces that are not fully bounded. So you would want to go back and check those and make sure that they are set up the way you want them to be, or maybe they do need to be deleted and rebuilt or whatever. But it's quite a comprehensive report for you to check through. So once you're happy with it, just import the geometry. And we can see our model there. Now don't get me wrong, that for demo purposes that is about as straightforward as it could be. In reality it might be quite a different experience. Okay, so we've brought the geometry in. The other things that we can do with that is to look at this, for example. Not that. Just select all the rooms and we can get a little Excel friendly report out. Now again, I know that the text's far too small to read here, but basically I've got all my rooms with all the room names brought across in the GBXML, a room ID, so that relates to the room ID in whatever originating software the model's been created in. I can actually change things in here as well. I can interact with this. So everything that's set as a room is fine. If there are rooms which are actually coming through as shading elements and things like that, then you can change it. You also have reported here again the room volumes, the floor areas, opening areas, which level of the building they're on, all that sort of thing. So you can check again through this mechanism to make sure that everything's set up as it should be, or make changes where necessary. I haven't applied any room groups, but that is something that I would definitely do because it makes it a lot easier when you come to assigning data to the geometry a bit later on. So I'll do a little bit of that and then I'll open up a model that I prepared earlier. So room grouping. We just want to have the rooms there. So yeah, everything there from basically the import status sorts out the geometry as it comes across. So it actually groups rooms together or surfaces together as well, based on whether they were extruded from the 2D plan. In some cases where the 3D geometry that the software is presented with isn't of a great quality, i.e. there are lots of gaps in the rooms and things like that, and it's not getting bound volumes, it will look for 2D geometry and it will use that to extrude to 3D, and it will incorporate any doors and windows that are shown in the 2D as well. So that's a kind of an interim step, if you like, in the process. But what I want to do is really to create a separate set of room grouping. So zones. I'm just going to set up some zones based on the room activities. Okay. It's a little school, so we say teaching space, office, and meeting room. Now you can do this as well from the tabular room data that I showed you a minute ago, but I'm just doing it the old-fashioned way. So everything's on ancillary, which is good because most of the rooms, that is what they are. So I would just then click down and I would say all the meeting rooms, I want them to be on the meeting room room group, because then I can assign data to them as a group. Okay, and then open plan office, for example, same sort of thing. Okay. Means that you can change, you can make global changes to groups of rooms rather than having to change every single one. Okay. So I think at this point I was going to open up another model, which I've just sort of done a little bit more work on room grouping and cleaning up the geometry a little bit. And going back to where we were in terms of analysis, I'll switch off the room names again. The next thing that I wanted to look at was natural resources. So for this, it does take, it does an annual simulation now basically. Because what it's doing, it's going to say what potential there is, as I say, to offset electrical demand, basically by using available solar and wind energy for that location. And in true demo fashion, here's one I prepared earlier. So that, while that's running in the background, go away. I've got a report here that I did. This is what the software is going to spit out, this report, in a second. So it'll tell me that, a percentage of the annual building electrical load could be offset by using PV and or wind, and also that I can potentially collect however much rainfall to use for flushing toilets and all that sort of thing. So that's quite a straightforward one. Just let that run in the background. And so basically all this is done very early on, so I would say sort of briefing, concept design stage. Quite quickly, arguably, you're able to get a lot of feedback out of this just by running through the very sort of basic analysis. We're trying to minimise the time in setting up the data as well, so there's tools like, for example, master templates, where you can encapsulate a whole design within a template. And as your BIM model changes, as the design progresses, the geometry changes, you import a new model, at each stage or every month or every week or whenever it is set in the programme. For your particular project, you can apply that template of data to the geometry each time. So you're not overwriting all of the constructions and the thermal templates and everything every time you import new geometry. You don't want to be doing that. So we're trying to speed up the whole process as much as possible and really encourage iteration right from the start. That's where the value is in what we do. Okay, so I was just going to run through some more of these reports. We'll do the solar one, for example. Again, as I'll keep saying it, but it's early stage, so we want a simple model and we want to be able to just quickly run it through these different analyses. And we can build up quite a lot of information very quickly and feed that back to the design team, to the client, and get decisions made and stuff. So this is basically a solar intensity image. So we're showing annual average solar intensity on each external surface of the building. You can use this to inform your shading strategy. Obviously, if I had the OSM data around about this building, I can take that into account as well. And we can use it for positioning PV on the building. So we've got quite a good availability for the roof of this building, for example. What we can also do here is we can superimpose the sun path based on the climate data that we've got. So we know what the solar azimuth and altitude is. We can sort of set it for, well, every day, every hour of the year basically. I've set this for noon, and then you can just sort of go through each month. You can assign the shadows as well, so you can say, okay, I want to look at, you know, March or whenever the solstices or the equinox, for example. What is the situation? Just from an external perspective, I mean, we can get into the building and look at what's happening internally with sunlight and stuff, but this is really just early stage visuals to explain your strategies. And you can animate it as well, so that's all dead straightforward. If you get a simple model through, you can do all this, I would suggest, in a morning. Okay. Right. Okay, so other things that we would do at this stage would be perhaps to look at daylighting. We can look at energy and carbon, obviously. We can look at the building heating and cooling loads, so steady state heating and cooling loads calculations, and export all of that information to Excel, which can then be pushed around back to your BIM tool if that's what you want to do. And I guess maybe concept design stage, we would want to start doing preliminary compliance checking with Part L. So we can do that. I'm just going to use SBEM, set the methodology. So is it EPC or is it, sorry, that's disappearing off the edge of the screen. But is it EPCs or compliance? We'll go with compliance. And we've set the location already. We can select the building type, so it's going to be a primary school. We can look at constructions, and we can make changes there. We can add blinds in, we can put more insulation in, we can create our own constructions and do whatever we want to with that. And then when we're ready, we would just hit the run calculation button. Okay, so all of these things, quite quickly, building up a picture of sort of key design priorities for this particular building in this site, and being able to push that information then out to other packages. So there's quite a good example from an event that we ran recently of one of our customers using BIMlink to take non-graphical data from the VE back into Revit was the tool that he used. So there's plugins, there's Revit DB as well, which will allow you to transport information from our software back, if that's what you want to do, and that constitutes the round trip or bidirectional workflow. Okay, so we can see now that we don't pass, so now we would go back through a loop of making changes to this model, maybe looking at different thermal performance of certain elements of the building. We can drill into that in a bit of detail as well. I think the other thing then early on that we would want to look at would be life cycle cost and life cycle assessment. So I'm going to hand over to Neil now just to do a quick 5-minute number, and then I'll finish off.
Yeah.
Okay? And we'll have some time for Q&A after that.
Yeah, so my name's Neil. So I work with Sarah in the UK, and one of the things I look after in the software is the costing capabilities. So looking at the capital cost and the life cycle costing of buildings. So over the last 2 days, we've heard a lot about exchange formats and data and how we integrate data into federated models and such forth. And what Sarah's been showing us here is, well, what do you do with that data? So, it's fine to have a model like in a drawing package, like stuff like Graphisoft, Vectorworks, Revit, or whatever drawing package you're using, but that information is fairly static. But what you need to know as designers or clients is how all that information interacts with each other. And that's what the virtual environment's all about. So for example, it's one thing to be able to say in a drawing, the external wall construction's this and the glazing's that. But actually, if you're going to change the glazing to solid ratio on your building, that has an impact on so many different variables within the room spaces. For example, if you increase it, then you'll get more solar radiance, so therefore your cooling load's going to increase, your heating load might decrease, there may be more daylighting, so your lighting loads will decrease, and all of this will have an impact on the building. And for sure, one of the main things that we look to always try to optimize in buildings is obviously energy. Why? Because that's cost. And so with the virtual environment, you're able to take that information from whatever project drawing package you have into the tool that Sarah's been showing you, the virtual environment, and optimize for all of these variables, for any type of building performance metric is what we call them in there. So one of the great things that's come out over the last 12 months has been the capability to really look at in detail the costing, and it's and at any stage of your project. So that's what we're showing you here, although Sarah's been focusing at the early stages of the project with a very quick analysis. You can use this tool to provide that quantitative analysis for optimization of your building through the very early stages in design, right the way through to the absolute detailed stages just before construction, and then obviously into operation as well, which is really quite exciting. Okay, so you can continually optimize how the building's running in operation. So it's really, when you think back to David Phillips' presentation yesterday, it's the operation of buildings which is the big win here. This is what the real drive and what we're doing with BIM. So I'm just going to have a quick look here on the costing side and bring this up. So I'm going to go back to my applications, and here you can see all the various applications or modules within the virtual environment. For those that use it, you'll recognize these. As I scroll down, I hit my cost and value section within the tool. And the two modules that I'm going to be concentrating over the next 2.5 minutes is going to be cost plan, which is the capital cost. And then obviously, once you have your capital cost in there, then as a subset from that, I'm able to provide my life cycle costing calculations using my life cycle module in there. These are the two that we're going to just have a very quick look at. So I'm just going to click and bring up the view here on the capital cost side. Now I have to say, just for those that, because I recognize a few users of the software, you'll know the software being from a background of thermal analysis, okay? And therefore, historically, we haven't taken into account of elements within the building that are non-thermal. But actually, this tool is fully comprehensive and takes into account of absolutely every nut and bolt that goes into that building, whether it's to do with the foundations, for example, or microphones, seats, or carpets, or whatever. It doesn't matter. It's a fully comprehensive tool there. And it's a great way, if you have a cost consultant on board who's a little bit reluctant to get involved in the integrated design process, this is the way to give them a wee kick up the backside. So what we have here is our model, and down here in our cost plan we have our costing methodology. This is the nuts and bolts of what we're going to be looking at. The methodology that we're looking here is recognisable by anybody who's involved in costing. It's called the New Rules Method, and it's actually compliant with the second edition, if you want to look there. Now, probably those at the back probably struggling a little bit to see exactly what we're looking at here, but on the left-hand side, it follows a very set structure. So it's looking at the building in relative areas. So we start off with the substructure, superstructure, internal finishes, services, and so forth, okay? And on the right-hand side, as I go through here, it will then break that down further. So I'm able to look here in detail at the costing of my glazing systems, my external walls, my roofs, for example, in the superstructure section, and so forth. I'm able to look at this in an overall glance within something called a cost plan. And I can see exactly here what's going on. And effectively, do you know what, actually, costing, it's not really that difficult. There's really two things that we need to keep an eye on, and that is quantities, so how much external wall do I need, what's my roof area, that kind of thing, and rates, how much is that going to cost? Okay, and it's just about compiling those two things together. Why would you suddenly want to do your costing plan in an analytical model? Well, there's a number of benefits here. One of the great things is you're able to benefit from your BIM model and taking quantities directly from that. So I'm able to link my cost plan directly to my model. It's going to make it a much more rapid process, but actually it's going to make it more efficient as well. But if the architect was to update the model, for example, let's say it needs to be reduced by 10%, then I can just refresh my model in here from the BIM model, and that will automatically update my cost plan accordingly. Okay, it's going to reduce a lot of time and therefore cost associated with it. Now, all this cost data that's in here can come from typically two different ways. We actually have a cost database that sits behind the virtual environment that I can actually draw in on, or secondly, which is probably going to be more commonplace if you're doing a more detailed cost plan, is you'd probably speak with the cost consultant on board or the QS. You'd get your hands on their cost plan or their bill of quantities, and you're able to bring that into the virtual environment in this space. So you're able to go down space by space, watch the roof, and into that data there. I'm just going to show you very quickly the data that sits behind the virtual environment, just to give you a flavour of what's available. Okay, so within the virtual environment, we have something called a library that sits behind in our construction database, okay? And that's where we specify our data and associate that to the building, okay? Don't worry too much about that. But this library is quite an important new feature to the virtual environment because it allows us to bring in third-party data sets there, ready for you to have. So you don't need to search for different brochures and manually bring that data and type it in. You're able to just simply access that by going into this library. This particular cost data set actually comes from the BRE within the UK, and it's something that you would subscribe to there. Now, hopefully you can see here what we're looking at. Within this database, we have lots of, these are all the different elements that are available. So what we can see here is external walls, but if I scroll down, there's literally thousands of different elements available. External walls, roofs, hard landscaping, and such forth. If I just click one and just show you the kind of data that's associated there, we have our description of what's available. It doesn't matter what that is too much just now. It also has the thermal data. So what's great about that? Well, that's when you apply this data, you're still able to run all your energy calculations. When we're analysing our cost data, the energy part is going to be one of the critical parts that are involved there. If we're optimising the building for cost, we need to understand the relevant impacts with the energy as well. So you might say, oh, well, it's easy to reduce your installation, that's going to save you money. But actually, in terms of the life cycle cost of that, you're going to need more energy to operate that building. And so you need to understand the net impact of this analysis. This is what this allows you to do. The next column here, I've got capital cost here, and this will change for whatever region that you are in the world. Okay, so here I've got a capital cost for this particular system of somewhere between 155 to 195 pounds per square metre, okay? And depending on the location of the building, when it's going to start building, whether it's going to be in 2 years' time, inflation increases the cost, or if it's going to be next week, obviously it's going to be a little bit cheaper. The complexity of the building, the quality of the building, okay? Now, all of that will change the relative cost that's associated there. The columns there and the data following that are all to do with life cycle costing. Life cycle costing is very strict in the way that we approach it. There's various European standards, for example, that we have to work towards, and that's all taken into account for you. Okay, this is one of the great things about this tool is that it really does break down the barriers to this quite costly specialism, if you like, into the general population of design. So anybody can, if you're an architect, it's an absolute superb tool for being able to keep an eye on costs at the very early stages. So here you're able to understand repair cycles, repair costs, replacement cycles, replacement costs, cleaning, decorating, all that kind of operating costs associated with this particular external wall type. And at the very end, something that I didn't mention, but it's also got the environmental impact of the tool here as well. So here I can see that I randomly have picked a very good performing environmental product. It's got an A+, which is terrific. And so here I can say, well, okay, maybe that's a bit costly in the capital costs. Let's pick another A+, let's go back. And I'm able to look at the cost of that as well. Now, the one I picked there is the same cost, and so I can then start comparing. But there, even in this library, I'm able to do a little bit of sensitivity analysis what's the kind of materials I want to associate with my building at the very early stages, even before I brought it into the modelling tool to do some sophisticated analysis. So that's available there for you as well, just to show you about that. So anyway, I can fully amend my capital cost plan to take into account of everything. So let's go down here and maybe add a little column. It's number 11. Don't worry if you can't see this too much. I'm just going to put in some consultant fees. Specialist support consultant fees, I'll put that in there. And in fact, I might override that and call that BIM assessor fees. Okay. Here I'm able to quantify this from the building, but I'm just going to do this as a user entered number. This is just to give you a flavour of what's available. Then I'm going to put in £20,000 for this, and that's times 1. And then that's automatically updated within that category and the overall cost plan of this building. Now, overall, the capital cost of this building is just shy of £5 million. Okay, so that's my benchmark. That's where I'm at, and I'm able to look at that information in lots of different ways. Ready-made graphs. I can cut and paste that into my own reports if I want to. It's pretty flexible in the way that we're doing. We're now ready to look at the life cycle costing element of this. So I now go into my life cycle module, which is for life cycle costing. I'm able to bring up my plan, and here you can see it still uses this new rules method, so it's still very friendly and familiar to the way that I'm working here. The difference now, though, is that it's not just looking at the capital costs or the construction costs associated with it. It's also giving me all the relative costs to do with this construction there. Maintenance, cleaning, operating, occupancy, and end-of-life costs. Okay, so it's hugely comprehensive, as it would do, because it has to meet all the relevant strict standards that are associated there. Now, straight away, I can see that my life cycle cost is about £8.5 million associated with the whole building, but I can drill into any part, any nut and bolt within the building and optimise that. So how would we do that? We have a full data view again, where you can drill into those relative parts and change and optimise elements of the building. So for example, maybe the fire doors I've got there, the cost consultant has managed to get them for budget cost, which is great, and maybe they're very high performing. I can amend all of that within there. And but absolutely at the very core of this capability, this is the golden nugget of lifecycle costing. It's been able to automate your net present value calculation sheet. Now, when I first started out in building services design, within my first week, my director, I won't name names, he wasn't very good, but he said to me, he said, "Listen, Neil, you're interested in sustainability. Could you produce a net present value calculation for this project that we had?" And I was given a book about this thick with second degree differential equations, and I had no clue what was going on. This literally does it for you, all automated. It's superb. What's the power of this? Well, you're able to see exactly what costs are associated where within the building over each year that you've specified. So the European standard of analysis, which happens to be the same as BRIAM, is a 60-year period. So this is the year column. This is all the way down, so 0 to 60 years. And also along the top line here, what we're looking at here is all the costs in that year for repairs, replacements, decoration, cleaning, operational costs associated with fossil fuels, electricity, water, occupancy, recycling, demolishing, end of life. Okay, so as somebody who's very interested in life cycle costing, it makes it very easy to then drill into, well, where are the large costs associated with my building? Okay, so I can go down here and I can see here, for example, in year 15, I've got a cost of about £190,000. So why have I got that cost in there? I'm able to go back into my calculations, drill into that, and optimise accordingly, and try and reduce the operational costs that are possible here. So that's very, very powerful. Again, you're able to cut and paste that out. Again, we've got lots of nice reports that are automated. So you're able to understand your discounted and non-discounted cash flows for the building and so forth. It's a little bit skewed, this one, but there you go. Now, this particular graph here, this really emphasises the whole point of why we must take into account of the life cycle analysis of buildings. Okay, Particularly if you've got clients that are building owners, airports, hotels, government buildings, hospitals, schools, the contractor will always try and shave cost off the capital cost, the construction cost, that's fine, but it's a very difficult task to do. The real big win is on the life cycle cost, and we can see that here. Everything in red there is your capital costs, everything above that is your operating costs. Generally, it works as a 1/3, 2/3 rule. So 1/3 for construction, 2/3 for operating costs. So the chances of being able to save 10% on your construction costs could be very difficult, whereas you can more than likely exceed that saving within the operating costs. And that's why this type of calculation, I believe, should be more profound anyway. But the whole point of this particular tool is about breaking down the barriers to the specialism. At the moment, life cycle costing is done by very few within the industry, and they have very high fees associated with the building. A building of this size, let's say it's just a typical commercial block, you could be looking at £20,000 to be able to provide a life cycle costing report on that. So it's very easy as a client or to advising the client to say, look, we'll just cut that out. But when you think about the amount of money that client might be subject to in terms of operating that building, or the value even to sell the building in terms of the operating costs, it's something that's well worth paying. So to be able to do it at this stage, even as as an architect or an engineer, as a contractor, whatever, for a lot less is going to be of benefit to everyone. Right. That's me, yeah.
Really good, thank you. Okay, so to pull it back round to what we started off talking about then, just to finish up, because it's 43, so we'll finish within the next 2 minutes. There's a lot of data that can be created. We can capture it, we can share it to a degree. We need to probably do more of that, and this being a BRE sponsored event, Impact's probably quite a good starting point with all the data that's held within there. How do we make that more available to a wider audience? So yeah, performance and soft landings, relating to what Neil was just saying there, having a very clear picture and being able to make decisions at design, but with an understanding of what impact those decisions have throughout the building's life. So by reducing that £190,000, we can look at it and we can make decisions about how we're going to reduce it, but what is the impact of that down the line? I think the final 2 points that I wanted to make today were, in the aftercare part of the building as well, there is a requirement to log energy consumption and to review that on a fairly regular basis. We can do that using the tools that we've talked about today. And also, and that thereby keeping the data alive. But I suppose finally as well, as I said before, the more data that buildings are going to produce, the more clever ways we need to be able to utilise that data to view it, interrogate it, and make decisions on it. And that's really the future. So BIM to big data, which has been a bit of a theme as well. Okay, done. Questions? Anything? Yes. Good. Yes, can I? Okay. Yeah.
What formats can you save IES into?
What can we save it into?
Yeah. So
The model,
yeah,
you
so
mean?
obviously if you put the accommodation environment,
Yeah.
what you do save it in there?
It would have to go out as GBXML. Yeah. At the moment, we're still sort of here and there with IFC.
Okay.
I mean, we can
Is that
import
something that's
IFC,
gonna
but yeah, absolutely, yeah.
Okay.
Of course, it's got to happen. Yeah. So there's no ifs or buts about it.
I have a couple of questions. First of all, is there a provision of you mean orientation in IES?
Yes. Yeah, absolutely. Yeah.
Because you told about the location, but you didn't know how to be oriented.
Yeah, orientation. Yeah, absolutely. Just a little arrow at the top there. So you can just put in site rotation. But yeah, you can absolutely change that.
So there's the provision to amend, it's a very accurate tool, so there's the provision to amend any kind of variable with associated with building at all, anything. You can do there. But actually, interesting, things like that, there's tools there to do multiple simulations at once. So for example, the orientation, we've got tools that allow you instead of manually changing the orientation, you can say, like, I want to explore orientation between 0 and 360 degrees and 5-degree steps, and it will automatically build the calculations for you. Tools like that.
One thing is, I think there are challenges in exporting GPXML and IFC into IES,
Yes.
Catenda, everything.
Yeah,
Is there any guidance of
yes,
how we monitor?
sure. There's a white paper, so yeah, I should have probably mentioned that at the beginning. There's a white paper, and if you go to our website, iesb.com, we've got a YouTube channel which goes through the white paper's about 36 pages, I think, and it's quite, it's quite small to get through. But there are little videos of how to prepare the model and how to actually do the export. I mean, we run workshops on this all the time as well. You can submit your whatever Revit file or ArchiCAD file to us. We'll review it and we'll feedback to you as to what steps need to be taken to. Basically, though, in very simple terms, it's a bound volume, a clean model and bound volumes. So the walls, ceilings, and floors should join up.
So if the model is coming into only bound volume, how it affects on the costing? Because he's saying can do that in rows, so this detailed model can be bring into IFT? Or the second question is that costing, is it connected to the UK market? The data coming from?
Yeah, so the costing capabilities of the tool are totally international. So Sarah said at the start there, our software is used in over 140 countries around the world. It is the market we do in building simulation. And because of that, we have to make tools that are bringing benefit to all regions of the world. The costing is no exception. The BRE data that I showed you is UK specific. However, when you do costing, there is no such thing as generic data, if you like. So when you're doing detailed costing, which is 99% of the time what you'll be doing, that data will come from the QS or the cost consultant, because even if you're working on the same construction team on the same project next to each other, ultimately it's down to what agreement's been reached. A Kingspan panel, for example, might be struck at £100 per square metre in one project, and then somehow on the second project it's £50 per square metre. So you would take that specific cost from the cost consultant, you'd be doing that anyway, and then you feed that in there, and it's a very detailed
Detailed design.
yeah, detailed design.
There's a scheme cost plan as well, so you can use that as generic, but just for meter square rates and stuff like that early on, just to get a feel for it. I mean, personally, I think it is really important to do as much of that sort of thing right at the start of the project, rather than what is the current situation, whether it's BIM or not, 2D or 3D. Everything's done at the back end when it's too late. All the cost of making changes is yeah, I mean, when Neil was talking about nuts and bolts, I think he was using a phrase rather than actually pricing each nut and bolt.
No,
There is
I
a
do mean that.
Okay.
So you can go down to that level, absolutely. There's nothing that you cannot take into account of the cost. Obviously, from the model though, there's two types of data, right? So some of the data you can link to the model, and you can take the quantities from the model. Other quantities will come from the cost consultant's cost plan, for example.
Yeah, okay.
But for example, if you said, let's say you knew there was a rate of something like 5 nuts per square metre, then you can do that based on the model as well. You get quite intelligent about it. It's quite good.
Very impressive.
Thanks very much.
That's why I dragged them up.
Within the life cycle cost analysis, can you integrate holistic future and other data to see the effect on the future operation energy?
Yeah, absolutely. So one of the absolute key points about using the virtual environment is that we're like, I'm not going to say we're the most accurate, but we're certainly among the most accurate energy prediction tools that are available in the market. Okay? And so there you're able to analyse in a high degree of detail accuracy of the energy, whether it's today or using future climate files. It's entirely up to you. You can then feed that into the life cycle costing tool that I showed you there. And of course, bringing your costing analysis, which at the moment is very much done as a separate entity, you bring that in there into the BIM thing there. And this is the whole benefit of doing that, is that you're sharing data. So, yeah. So
And what about the optimization tool? Is it
The optimization tool is a really great tool there. I sort of use that as a sort of an orientation. So we've started, we have a dedicated optimization developer team At the moment it's about 5 software developers strong. We've been working on it for about 5 years. And what we've got now is our first phase 1 tool that has been released free within the software. And that's where you're able to do these parametric batch simulations. It's in a tab called Design Options if you use the software.
So is it one objective based or several?
No, at the moment it's purely looking
yeah.
at it's looking at variables and it's looking at a range of options within that. But we will be moving to the next stage is to build in constraints and objectives to that as well. Yeah.
With 2015, which is next month, we see quite a big step forward in the capability of that. Yeah, me too. I'm texting it yet.
But just to give you a bit of background to that, for everybody else who might not know about the optimization project, I mean, the idea now is, currently with simulation software, what you do is you replicate the building within the software. So you say, you know, the external walls are this, the orientation is that, and so forth. And then you press simulate to get an output. Okay, you then look at that and you say, look, did that meet the goals of my project? And, or maybe it wouldn't. So you then manually have to go back in and change something using your experience and knowledge to do that. And you continue this process. And we sort of very flippantly say that this is the optimum solution once we get to the end of this. But it's not really what we call true optimization. What we mean by optimization is taking a building form and being able to optimize for every variable. So check out, you know, a huge range of external wall constructions, orientation, HVAC systems, and so forth, and running every single one of those permutations. And then being able to drill into what could be 10, 20,000 simulations and finding the optimum solution against the goals of your project. So optimize against things like daylighting, life cycle cost, BREEAM, RL regulations. So that's what we're working on. Very, very exciting doing that kind of stuff. But I know you can tell I have too much coffee today. But,
One last about the post-occupancy evaluation. Is there a bi-direction link for anything goes into FM in the content? Can do it post-occupancy evaluation?
yeah, so we've got a great tool there called Ergon, which has then opened up this entire operational stage of analysis with the virtual environment. So the virtual environment can now be used at the early stages of design, as Sarah was talking about, and actually be passed with the building into construction to help optimise commissioning, and then can then be passed as an actual tool. We can give them a laptop to the FM team, and they can then continually optimise the building going forward. It's a great part, it's all part of the same things. Now how that works is we have a tool called Ergon. It's a cloud-based tool. What you do is you effectively stream the building data to this cloud service, which will then in turn stream that to your virtual environment. So you don't even need to be on the site, you can be anywhere in the world looking at this building. That allows you then, as a designer, to take your, to calibrate your design model against actual operational data. And then you're able to then quantify the performance gap in real time. So you're able to say, that's what I had to design, that's what I'm achieving, why is that? And then as you go forward, you can then say, well, let's look at the chiller performance. Has it been dropping off over the last week? Why? What did it do last week? What did it do last month? What did it do last year? And this kind of information is absolutely critical to truly understand how we run buildings in the future. But the key point is, those who are typically at the design stage are able to offer extended services into the operation stage. It's using the same tool that they use to design the building. It's the same thing. It's not, you're not having to relearn anything. So it's very easy to pick up.
I did have an example of that to finish off with, but I thought everybody was sort of, yeah, had enough by then. I did ask the guy in our Glasgow office that looks after the Ergon design plans to send me through, you know, a real building profile for lighting, which we did a sort of a simulation, but don't worry.
But I mean, if you come and speak to me, I'll give you contact details and I'll send the information through for you. Yeah, it's 4 o'clock pint time. I think everybody's got to that. It's a beautiful day out there, honestly. It's,
4 hours of sunshine there.
Thank you.
Thanks very much for hanging on till the bitter end. Well done.
yeah, thanks a lot.
There's cards at the front, or if you have any other questions you want to. But thanks very much. Thank you. Chris Groom, wake up.